Okay, so how we started here? We checked first, okay, if we are able to find here this value, but it's very, very small. That is 3 divided by 125 we are getting. So which is not an option, and even it is very, very small. It is in centimeter. So we started like, okay, let's try with momentum, because anyhow, there is a spring. It will have momentum if you stretch, if you leave it freely, it will like move up and down. It will have momentum in that. So we found momentum. But for that we need velocity. So we just use this velocity by third equation. Then with this we found V. V is 20 by 5 under root 20 by 4 under root 5, which is 5 root 5. So that is what we are doing here. And we are just equating with maximum velocity. That is kinetic energy. We're just finding with kinetic energy. So finally we are getting what? X equals to 2, which is not an option. Our calculation is correct, so it might be option wrong. Any doubt in this question? Are you able to understand? Others? You want to scroll up or down something? Are you done? Shall we go for next?
Okay.
Okay, let me search some other question. It's good. It's old question. It's easy. Try it. I think so. You can solve it. Come on. Let's give a try. Just think what we need to know and go with like what is the answer required. Okay, go from bottom. It will be easy way to reach. That's what I started here. I want like, okay, kinetic energy. So further in velocities. Okay, with velocities I can find by momentum. For momentum also we need V. So that's what I went with bottom. It's easy way to reach. So the time dependent force F equals to 60 acts on a particle of mass 1 kg. If the particle starts from the rest, the work done by the force during first t second will be what? We need to find time here. No. Okay, work done we need to find out. So work done in terms of it will be here kinetic energy. So how to find kinetic energy? Yes, dear. Are you able to solve? Easy. Those who are not able to speak, they can send your answer in chat box. Mohammed Jafar, I want answer from you. Mohammed Jafar Sadiq. Yeah. चलो बच्चा आंसर बताओ. Yes, Shruti, are you able to solve? Sainiyati?
Yes, sir. I'm doing.
Good. Sainiyati, are you able to? Tanishq? Okay, enough time. You're wasting so much time, taking so much time. Not more than 3 minutes you should take on one question. Mhm. Not good. Speed up. Okay. So let's start with force equals to by second law dp by dt. P is what? Momentum. Change in momentum. Delta P. Let's take change directly. No need for this one. Delta P by delta. Now, how will you find delta P here? Equals to F delta T. That is what we are going to do. For therefore, P will be equals to F dt integration. What's the limit here? This one, 0 to 1. So F is here 6t. 0, 2, 1, which is equals to 60 squared by 2, 1. Three. So 3 into 1 minus 1. 3 into 1, this 3 kilogram meter per second momentum. Okay, we found momentum. Now, why we are finding momentum? Because we are going to change. We need to find work done. Work done in terms of kinetic energy. Change in kinetic energy by which theorem? Work energy theorem. If you remember, Kf minus Ki. That's what we wrote. So delta K equals to here delta P square by 2m. P square, that is 3 into 3, 2 into m. What is m here? Okay, 1 kg, which is 4.5 joules. Easy? Understood? And again, I'm reminding that 25 questions are most important. They are gift. You should not leave those questions. At least you try something. Okay. Yeah, those are analytical questions. They won't have any option, but still you need to solve conceptual question. And you have to write answer there. Okay, and yeah, make it to round off to 2 decimals. Always. 2 or 3 max. Okay, let's go for next question. Conservation of momentum, x direction, y direction. Yeah, let's try this way. Yeah, this you will be able to solve. Okay, there is a hint given. Nice. It's old question, no? That's why. Shall I paste with hint or without hint? Let's paste with the hint. You try this. See, there's a hint given. This question. It's I. So what they're saying, when a rubber band is stretched by a distance x, it exerts a restoring force of magnitude F equals to AX plus BX square, where A and B are constant. The work done in stretching the unstretched rubber band by L. Okay. Work done in terms of F. Sorry, W equals to F S. So F into dx. Here x, that's right. So we will integrate. Integration of F dx. That's it. Come on, solve it. I want this answer. You have to solve this. You need to solve in 1 minute. Don't take much time. It's 21:06. I'll give you only 1 minute to solve. And yes. 20 seconds up. Yes, I'm up. Come on, tell me answer.
Sir, I got C.
C. Okay, C as a, okay, A by A L square by 2. Okay, fine. What about this? If all are getting C, then that is the correct answer. If any other option, then we'll see that. Yes, Vishwanath, it took so long. Integrate. C, okay. Okay. Tanishk, they both are saying C. What about you? Okay, let me try one in 1 minute. Am I able to solve or not? Let's check. Okay. Here, it's okay. Let's start. Ax squared by 2 plus bx 3 go to alpha. Fast. L square by 2 plus bl cube by 3 minus 0. Finished. Yeah. 49 seconds. You are taking so long. See, I finished in 49 seconds. Doesn't matter. It's okay. Everyone got answer, right? By the way. Okay, Shruti gave answer. What about Tanishk? Tanishk? You got it right? Sainiyati? How to you? Chanakya, how about you? You got it? Okay, you can text it, okay? Yeah, statement question. Do you know statement options? A, B, C, D, what are the options you know, right? A will be first and second, both statements are true and second statement is correct explanation. B will be one will both are true, but B statement 2 is not correct explanation. Third one, it will be statement 1 will be true and statement 2 will be true. Fourth one, statement 2, sorry, 1 will be true, second will be false. What they're saying, statement 1, two particles moving okay. Two particles moving in the same direction do not lose all their energy in a complete inelastic collision. Complete inelastic collision. Okay. The principle of conservation of momentum holds true for all kind of collision. Okay, that is true. So is kinetic energy is losing? See, I want an answer from you all. Yes, guys. Vishwanath, Ganesh, Shruti, Sai, Zafar. Answer this. Is both statements are true? Okay, tell me your individual answer. What do you think, Vishwanath? You can type also, no problem. Both statements are true, yes or no? Just say yes or no. I don't want so big long explanation. Just if is both statement true? Okay. What about Tanishq? What do you think? Is both statement true? Tanishq? Both are true. Shruti? Just say yes or no. I don't want full answer, no problem. No answer? Shruti? Acha, only first statement is true. Okay. Shruti, what do you think? Okay, so let me give you a small explanation by solving something. Let's prove it. So for inelastic collision, so m1 v1 plus m2 v2 will be equals to, after just writing m1v plus m2v. They do not lose momentum also. Okay. Why we are doing this? So that this object of mass m1 moves with velocity v1. Okay, so this object will have m2 v2 velocity. From this one we can find v m1 plus m2. So m1 v1 plus m2 v2 by m1 plus m2. That's what we found by in that during equation. Okay. So ke for it will be for initial and final. If we add those, p1 by 2m1 plus p2 square by 2m2. Therefore, what we can say by this one, that p1 and p2 both together cannot be 0. And yes, this is true explanation for first one. So both are correct. And you know, right, how to get this value? Half mv square. So it is p square by 2m. If we use this equation in previous question also. P square by, we need one, we have p square means it will be square. So dividing by m. Okay. I'll give you some 3-4 question. I'll paste it here and okay. This is the time which I gave exam. This is my exam paper. Solve this. You can take a screenshot. Wait, not now. Let me post 4 questions. Then you can take screenshot together. Two more. One more. This one is solved. Want some tower question. Just 1 second, let me search some good question. Okay, take a screenshot. This 4 question for homework. Have you taken a screenshot? Then let's do one more question. We'll do one question here, then we'll end the meeting. I want to try here. It's very easy. Try this question. Okay, but you have taken a screenshot, right? Try this question here. It's very easy. Come on. So next class will start with next chapter. They want instantaneous power. So instantaneous power formula, force into velocity. So find force, find velocity, and substitute that. Finish. Option A, B, C, D. Which option? We'll solve here. Simple. F equals to ma. A equals to v minus u by t. U is 0. V by v equals to at. Fine. Here m equals to v by t. We can substitute. Instantaneous power. Fv. F equals to mv by t. Here v we wrote as at. At will get cancelled. No need to write this one. We need in form of p and t. So we don't want a here. No. Don't write here. We want in terms of v and t. We already have v and t only. So at. So v by t. A is v by t. Okay. Time t, capital T, m b square by this t square into t, this t. Yeah, sure. T square, so mv t square. So do we have option like this? Mv square by t square into t. There is option A. Instantaneous time t delivered to find time t. Okay. Okay, fine. So any doubt in this question? Shall I stop sharing? Yes, sir. Okay.